Buongiorno students, welcome to Algebra 2 in the number plane. Now we're looking at number patterns and substitution. So it's important you listen up, you're going to learn a lot and take some notes. So there are patterns that we use that you can very quickly see, and it doesn't take much time to work them out. Here we have the 2 times tables, 2, 4, 6, 8, 10. You could probably create a term very quickly, so an equation to work that out. So here's my pattern. So 2 times a number, so the first number is 1, second number is 2, etc. So t equals 2 times the number. Here's another one. 7, 14, 21. Yes, it's the 7 times tables. So again, I can quickly see patterns and derive rules quickly. So t equals 7 times n. So the first number is 1, so 1, 7's a 7, 2 7's are 14, etc. But not all patterns are that easy. So we actually have to look at the pattern more carefully to work out and derive the rule. Here we go. So we always take an input, such as the first number. Then we use an equation. So that equation will manipulate the number. And then we're going to have the output. So the output's that pattern that we're looking at. So we take the input, we use the equation, and we get the output. Can you work out this pattern? Here we go. So I've got a 1 as the input, and output is 2. When an input is 2, the output is 4. When the input is 3, the output is 6. Have you worked out the pattern? What is the equation? Here we go. Times 2. So all the way along, 1 times 2 is 2. 2 times 2 is 4, 3 times 2 is 6. Okay, so I can very quickly create a term or an equation, t equals 2 times n. Now, in my original pattern, what I want to actually do is lay out my pattern. So obviously this is the first one, 2, 4, 6, 8, 10. And I'm actually going to, above it, put my first number 1, 2, 3, 4, 5. So that's my input, the pattern's the output, and this is what I'm actually looking at. This helps me derive the rule. I look at my output and see the change between the first and second output. So between 2 and 4 there is 2. Okay, between the second and third, so 4 and 5, what is it? It's the same, isn't it? 2. So all the way along, I can see this pattern. And here's my rule. This is the trick. This is the $1,000,000 question. What do I do with it? Here it is. The output, so my pattern, equals my input times the change. Did you get it? So the output, so that's the pattern, equals the input times the change. So here we go. Let's test it. 1, so that's my number, n, times 2 is 2. 2, that's my input, times 2 is 4. So that's the t. And again, 3, that's my input, times the change, 2, there's the 2, 3 2's are 6. So it works. But what happens with more complex number patterns? Have a look at this one. 3, 5, 7, 9, 11. Now there is a pattern there. So I do the same thing, and I can see between the first and second number, 3 to 5, it changes 2, and again from 5 to 7, so the second number and the third number, 5 to 7 is 2. So it's the same thing. However, when I put that into my equation, 1, so that's the first number, times 2, the change, I get 2. Hold on. It's meant to be 3. When I put in 2, the second number, 2 times 2, the change, I get 4, but it's meant to be 5. What's missing? There's something missing. Have you noticed a difference? Here we go. The last part of the rule. We add or minus the difference. So if I look at the first number, I get 2, but the answer is meant to be 3. And in the second one, I get 4, and the answer is meant to be 5. Have you noticed the difference? This number here, the first one, is 1 less than the 3, and obviously 4 is 1 less than 5. So what I have to do is actually add the difference. And what's the difference? 1. So let's try it. 1 times 2, it's the same as there, but I'm adding the difference. 1 times 2 is 2, plus 1 is 3. Yes, it works. 2 times 2 is 4, plus 1 is 5. There it is. Beautiful. So I take the input, times it by the change, and add or minus the difference, depending on what is happening with those numbers. So from